In this tutorial, we'll discuss section 11, the learning objectives. First, to understand that chemists use mole to count atoms, molecules, ions, formula units accurately. Define mole. Mole is the SI unit, base unit, which is used to measure amount of substance. 1 mole equals 6.02 times 10 power 23rd representative particles, and the abbreviation of mole is mole. Explain why chemists use mole. Because it's a convenient way, means a simple method to know the number of representative particles in a sample. It allows chemists to accurately measure the amount of atoms, molecules, formula units in a substance. 3. State the mathematical relationship between Avogadro's number and 1 mole. 1 mole of any substance contains Avogadro's number of representative particles. So 1 mole of any substance contains the same number of particles. 4. Describe using particulate diagram types of representative particles. Representative particles might be atoms, ions, molecules, like covalent compounds or formula unit in case of ionic compound. Also, you should be able to use accurately this triangle to measure and calculate the number of representative particles in a given sample in moles of an element or a compound. If you need the number of particles, you should cover this part, the number of particles. So you will multiply the moles times Avogadro's number. If you are asked about the moles, cover the mole. You need to divide the number of particles over Avogadro's number. And don't forget to use a correct unit. In KPI 11.6, you will learn what is the average atomic mass, what is its unit. Average atomic mass is the weighted average mass of the isotope of an element, of all isotopes of an element, and it has a unit AMU. Suppose you have 2 isotopes for chlorine, Cl35 and Cl37. Cl35 has an abundance of 75%, while Cl37 has an abundance of 25%. How to calculate average atomic mass of chlorine? You are going to multiply and add, like this, over 100. You write the isotopic mass times its abundance plus the second isotopic mass times its abundance. So you will get the final answer, which is equal 35.45. In 11.8, you need to learn how to calculate the average atomic mass. Okay, if you are given the percentage abundance of each isotope of an element. You are going to practice so many questions like this in the coming worksheet. In 11.7, you need to remember again what are isotopes. Isotopes are atoms of the same element that have the same atomic number and different mass number due to different numbers of neutrons. Remember the table that we used to use, which we can use it to calculate the number of protons, neutrons, and electrons in an atom. If you have an element like Cl37, and I will ask you what is atomic number, mass number, neutron, proton, and electron. You will get that atomic number, you will get the number from the periodic table, it's 17, mass number is 37, number of neutrons equal mass number minus atomic number. So 37 minus 17 equal 20. The proton, which is equal the electron, and atomic number in the same time, 17. While Cl35 isotope has also atomic number 17, but mass number 35. If you subtract to get the number of neutrons, you'll find that they have only 18 neutrons. Number of proton and electron in neutral atom always equal the atomic number. So the difference in the mass number between the two forms of the elements are due to different number of neutrons. We call those two forms of chlorine isotopes of chlorine. In 11.9, you will define and calculate the molar mass. Remember, what is the molar mass? The molar mass is the mass in grams of 1 mole of any substance, and it has a unit gram per mole. In 11.10, you will be able to calculate the mass of an element or a compound if you have the moles and vice versa. You will be able to use this formula. Here, the mass in gram, N, which is number of moles, and M, which is the molar mass. And the N is the number of moles. So if I ask you, what's the mass of 2 moles sodium chloride? First, you should calculate the molar mass. Molar mass of sodium equal 23. Molar mass of chlorine is 35.5. You'll get those masses from the periodic table. So the mass of sodium chloride is 58.5 gram per mole. Okay, so in order to calculate the mass, you need to multiply M by N. So 58.5 times 2 moles. You will get the final answer in gram. In 11.11, we will define atomicity, okay, and relate this number to the subscript of the chemical formula. Here we can say that atomicity is the total number of atoms present in one molecule of an element or a compound. So, if we ask what is the atomicity of H2SO4? H2SO4 has how many atoms? Look for the subscript written here, 2. So I have 2 hydrogen, 1 sulfur, and 4 oxygen. The total number of atoms are 4 plus 1, 5 plus 2, 7. So the atomicity of sulfuric acid is 7. What is the atomicity of HNO3? 1 plus 1, 2 plus 3, 5. What is the atomicity of H3PO4? 3 plus 1, 4 plus 4, 8. If we say CaOH2, I have 1 calcium, 2 oxygen, and 2 hydrogen. So total number is 5. This is the atomicity. But if I ask what is the atomicity of oxygen in each of those, here is the atomicity of the whole molecule. If I'm asking about atomicity of oxygen, you need to look for oxygen only. I have in this formula for oxygen, and in HNO3 we have 3, in H3PO4, 4, and in calcium hydroxide we have 2. In 11-12, we will calculate the number of atoms in an element or a compound if you are given the mole and vice versa. What is the formula that we'll be using? You are going to use a formula which say that number of atoms equal N, referring to the number of moles, times atomicity times Avogadro's number. Because Avogadro's number is the number of particles, if when you multiply N times Avogadro's number, you will get the total number of particles. If you need to calculate the number of atoms, so you should use atomicity, which is the number of atoms in the formula, to get the total number of atoms. In the last KPI, you will learn how to calculate the number of atoms or ions in an element or a compound using the same formula, but sometimes you are given the mass. So in this case, you need to change mass into number of moles by multiplying the number of moles into mass equal number of moles into molar mass. So if you are given the mass, you should calculate the number of moles and then make use of the number of moles into the formula. Let's take an example. How many atoms are in 98 grams sulfuric acid? So you should first convert grams into moles. So you will say the moles of sulfuric acid equal mass divided by the molar mass, which is also 98. So we have 1 mole. Here the number of atoms equal N, which is the number of moles. We have here 1 into atomicity of sulfuric acid 4 plus 1, 5 plus 2, 7, into Avogadro's number. 6 times 10 power 23rd. So the answer will be 7 times 6, 42, or 4.2 times 10 power 24 atoms. If you add a point to the question by asking how many oxygen atoms are in also 98 grams sulfuric acid. Here you will do the same thing by finding the number of moles, and then when apply the formula, I have 1 mole times, here you should use only number of oxygen atoms. The oxygen atom in the formula are 4. So 1 times 4 times Avogadro number. 6 times 4 equal 24, or 2.4 times 10 power 24 oxygen atoms. Let's start answering the questions. Question 1. Explain why chemists use moles. Chemists use mole because it is a convenient method of knowing how many representative particles are in a sample. Question 2. State the mathematical relationship between Avogadro number and mole. You know that 1 mole of any substance contains Avogadro number, which is 6.02 times 10 power 23 representative particles. Now this question is asking, list the conversion factor that used to convert to particles of moles and vice versa. Here is the conversion factor. So 6.02 times 10 power 23 particles over mole, or moreover 6.02 times 10 power 23 representative particles. Depend if he's asking about the particles or asking about the number of moles. And instead you can use the formula, which we can draw a triangle. Okay, you write here number of particles, and here is Avogadro's number, and to make it simple, just use 6 times 10 power 23, and the number of moles will be on the other side. Here is the number which we mean representative particles. So we can use this formula now to calculate here the number of representative particles. 11.5 mole Ag. So it contains how many particles? So now you have the number of moles and asking about the particles. Just to cover the particle with your hand. Cover this part, okay, with your hand like this. So you recognize that in order to get this formula correct, you need to multiply Avogadro's number times the number of moles. So if you multiply 11.5 times Avogadro's number, you will get the correct answer. And don't forget to change your answer into 3 significant figures. All your answer should be given to 3 significant figures. And the unit also is important. Here is the correct answer. Next question is asking about the number of moles. So he gave you the Avogadro's number and the number of molecules and asking about the number of moles. So now you should cover this part which represents the number of moles. Okay, so to do this calculation, you need to divide the number of particles or molecules given over Avogadro's number. here is the correct answer. Let me show you how to get it without using calculator. First one, 1.2 times 10 power 25 particles. You will divide it over 15 here. Okay, divided by 6 times 10 power 23. 1.2 divided 6, like 12 divided 6 equals 2. Here it will be 0.2 times 10 power 15 minus 23. It will be 15 minus 23 equal, yes, minus 8. So your answer will be 0.2 times 10 power negative 8 or 2 times 10 power negative 9. Just remember that when we divide, okay, just do the values first and then subtract the powers. Just remember, when we subtract, when we divide, we subtract the powers. Last question in this slide. Arrange the following quantities from smallest to largest in terms of mass. This means that you need to convert all of those quantities into mass, and then you can compare them and arrange them from the smallest to the largest. So first, you have 1 mole argon. To change it into atoms, into mass, just multiply it by the molar mass. The molar mass of argon, which is 36, sorry, it's 39 point something, so it's about 40. So 1 mole argon equal 40 grams. Then 3 times 10 power 24 atoms of neon. To change it into mass, you should first change it into mole. To change it into mole, you will divide by Avogadro's number. 3 over 6 equal half. 10 power 24 minus 10 power 23 means 10 power 1. Half times 10 equal 5. So we have what? 5 moles. Then you need to change the mole into mass. Okay, so we'll say 5 moles neon equal, you will get the number from the periodic table. Atomic mass is 20, so 20 into 5 equal 100 grams. And the third one doesn't need any change because it's already given in gram. In this way, you can arrange them in the correct order as follows. So we have 20 grams of krypton are smaller than 1 mole argon, which is smaller than 3 times 10 power 24 atoms of neon. Question number 7. Which contains more atoms? Is it 1 mole of silver or 1 mole of gold? As we have just learned that 1 mole of any substance contain the same number of atoms. So both of 1 mole gold equal 1 mole silver equal 6 times O2 times 10 power 23rd atoms. Question 8. Which has more mass? 1 mole of potassium or 1 mole of sodium? And you are asked to explain your answer. Yes, quantities are 1 mole. and they have the same number of atoms, but they don't have the same mass, because very logic, because they do have different molar mass. Molar mass of potassium, so 1 mole potassium equal 40 gram, while 1 mole sodium equal 23 gram. So I can say that which has more mass. I will say 1 mole potassium has more mass than 1 mole sodium. What is the number of oxygen atoms present in 0.5 moles in 2O5? Let's write the formula first. Number of atoms equal N, which is the number of moles, atomicity, number of atoms in the molecule, into Avogadro's number. Number of moles, half mole. Atomicity here, it's N2O5, means 2 plus 5, 7. Into 6 times 10 power 23. The final answer is 1.5 times 10 power 24 atoms. Next question. Calculate the number of oxygen atoms found in 18 gram glucose. First, you need to calculate the number of moles. Mass divided by molar mass. You should calculate the molar mass of glucose. Molar mass of glucose equal 180. 12 into 6 plus 12 plus 16 into 6. So 18 over 180 equal, yes, 1 over 10 or 0.1 mole. Then apply the formula. Number of atoms equal number of moles multiply atomicity. What is the atomicity of this molecule? 6 plus 12, 18, 18 plus 6, 24, into Avogadro's number. Answer is 6 times 10 power 22 oxygen atoms. Let's read this question. Lactic acid is mainly produced in muscle cells and red blood cells. It forms when the body breaks down carbohydrates to use it as a source of energy when oxygen levels are low. Lactic acid is an organic compound that contains carbon, hydrogen, oxygen. It has a general formula, okay, and he gave the general formula. And the N here is the number of carbon atoms. Student analyzed 18 gram sample of lactic acid. The molar mass of lactic acid is 90 gram per mole. Write the formula of lactic acid with 3 carbon atoms. He gives you the formula CN H2N ON, and he said that N represents the number of carbon atoms. So and he said here 3 carbon atoms. So C3 H 2 into 3 O3 equal C3 H6 O3. This is the formula of lactic acid. What is the atomicity of lactic acid? Okay, we have 3 plus 6 plus 3. 12. Calculate the number of moles found in 18 gram of the sample. Number of moles equal mass. So N equal mass divided by the molar mass. The molar mass is already given here, equal 0.2 moles. The number of atoms of hydrogen in the formula. The number of moles multiplied by the number of atoms in the formula, which are 6 times Avogadro's number. Hydrogen atoms. Here, what is the atomicity? Very simply, you are going to count the number of atoms in the formula. Here, 1 nitrogen and 3 hydrogen equal total of 4. Here, the total is 7. Here, 2 aluminium plus 3 sulfur plus 12, total of 17. We have a total of 3 and 8, 2, 1, 3, 5. Here 6 plus 12 plus 6 equal 20. 12 plus 22 plus 11 equal 45. Define mole. Mole is calculate the number of moles of sand found in 6.4 gram sand. He gave here the formula of the sand, which is SiO2. And he gave also the mass. To calculate the number of moles, you will divide mass over molar mass. Mass, which is 6.40, over the molar mass, you will calculate it from the periodic table. SiO2. So silicon equal 30. So 28 plus 16 plus 16, we have 2 oxygen, so the total will be 58 gram per mole. So you'll divide 6.40 over 58 to calculate the number of moles. So the answer is 0.11 moles. Calculate the number of atoms. To calculate number of atoms, equal N, number of moles, times atomicity, times Avogadro's number, equal 0.11 number of moles, atomicity SiO2 equal 1 plus 2, 3, times 6 times 10 power 23. So the answer is 2 times 10 power 23, or 0.02 times 10 power 25 atoms. In this question, he asked to find the number of atoms of oxygen, not the number of atoms in the whole molecule. So just instead of using the atomicity of the whole molecule, you will use the atomicity of oxygen, which is 2. Equals 1.32 times 10 power 23 oxygen atoms. Which contain more moles? He gave here atoms and here grams. You need to convert each of them to moles, and then you will be able to compare which contain more moles. First, for silver, Ag, 3 times 10 power 23 over 6 times 10 power 23 equal half times 10 power 23 atoms. And then for magnesium, Mg, equal, you have the mass, you will divide it by the molar mass that you will get it from the periodic table, 0.01 moles. Sorry, the answer here, this will be cancelled, so it will be half a mole. So which has more moles, silver or magnesium, according to these calculations? Okay, silver has more moles than magnesium. Boron has two naturally occurring isotopes, 10 of an abundance of 20% and 11. Okay, and you are asked to calculate the average atomic mass of boron. Average atomic mass equal the mass of each isotope times its abundance. So a first isotope is 10, its abundance is 20, plus second isotopic mass is 11, its abundance, the total abundance, remember, it's 100. I have one of them 20, so the rest is 80. So 11 into 80 divided by 100. So you'll get the answer 10.8 atomic mass unit. You will be able then to check your answer by looking at the periodic table, the atomic mass of boron. You will find it's very close to the answer we got here. Thank you. Use the data below to calculate the average atomic mass of a known element X and identify X. To calculate, I told you to draw a line. The denominator is 100, and here two brackets, between them plus, multiply, and then use the number given. The first mass is 6, its abundance is 8, second mass is 7, its abundance is 92. And you will get your answer in atomic mass unit. After doing that, you should look for this atomic mass in the periodic table to be able to recognize the element, because he said identify the element, so element X is lithium. Nitrogen has two naturally occurring isotopes, N14 and N15. They have these atomic mass. Which isotope is more abundant? If you look at this number, this value is very close to N14 than N15. This means that the isotope N14 is the most abundant. The isotope, and it is because the average atomic mass, which is 14.007, okay, is very close to N14 than to N15. You are going to solve this question in a very similar way. You are given two isotopes of copper, 63 with 70% abundance and 65 with 30% abundance, and you are asked to calculate the average atomic mass of copper. So average atomic mass equal the mass times abundance plus mass times abundance over 100 equal 63, which is the average atomic mass of copper. This question is very simple to get it answered. Atomic number never change for Cl, so it's 17. Zirconium also has the atomic number of 40. Number of electrons never change because we have neutral atom, so we just copy them. Number of protons, also copy them, they never change. Mass number, as you know, equal number of protons plus neutrons, or protons plus atomic number. So if I have a mass number 37 and the proton 17, you can get the neutron by just simple subtraction. Here will be 20. To calculate the mass number here, add protons and the neutrons. So 40 plus 50 equal 90. To calculate the number of neutrons here, mass number minus atomic number, 92 minus 40 equals 52.